Hello and welcome. The Omicron has arrived in India. The first few cases have been found. Now, the larger question is, it is, remember, just to put it in perspective, it was not that the cases would not come to India, it was inevitable. But the larger question, to some extent, that we're still asking is, why are we so worried about this particular strain of COVID-19 virus, knowing as we have this virus for more than 18 or 19 months now? Secondly, why is there so much panic in the way many countries are responding? And what does this say about the virus and this specific mutation? More importantly, we were always expecting mutations to come. We were expecting variations to come. We also knew that some of these mutations may have been more dangerous than the previous one. And conversely, it could have been less dangerous as the virus obviously evolved. So that's the question that we are trying to understand. The second part of the discussion that is going to follow is going to obviously focus on vaccines. In the case of vaccines too, the CEO of Moderna has said that he feels that the vaccine will struggle with this new virus. Now, why is it that vaccine makers are not confident at this point, and what's changed in either the construct of the vaccine as was created earlier, or is its potential to fight this virus or protect against this virus, more importantly? So to answer these questions, I'm joined by Professor Dr. Polly Roy, Professor of Virology at the London School of Hygiene and Tropical Medicine. Dr. Roy has provided in the past the first molecular description of a distinct group of viruses known as the orbiviruses. She has a PhD in molecular virology from the New York University. She also holds an Officer of the Order of the British Empire and a gold medal from the Indian Science Congress General Presidents. So, Professor Roy, thank you very much for joining me. We spoke earlier on a couple of occasions, particularly in the context of understanding COVID-19 and when the first vaccines were being introduced and trying to understand the efficacy of these vaccines. So now let me bring you back in some ways to square one. And what is it that you understand of this new variant, the Omicron variant, and why are we so worried and so shocked in some ways in the way we are responding to it?
Okay, first of all, let me tell you, you already said that the virus is in India. And it has been in different countries, I'm absolutely sure, for a while, even though we did not find out because they fortunately sequenced South Africa and they found out. So if it's really very dangerous, we have seen people dying in the street if the virus is around. So it is not as dangerous as people are making it out of it. So, for example, Delta virus variant. When Delta first came, everybody thought we're going to have severe disease and many, many deaths, which actually did not happen. And vaccine will not recognize, which is not true. Vaccine will not work, which is absolutely not true. It worked, even though there are really severe changes, drastic changes, I would say, in amino acid residue of the protein that binds to the receptor of the human receptor. So in this case, in Omicron strain also, there are a lot of mutation, it's true, because all viruses make mutations, okay? All viruses make. Coronavirus, in fact, makes much less mutations than any other viruses because it has a proofreading system itself, so they control it. So proofreading system is very important. If they don't have it, virus cannot be live anymore. That's the reason they have it, very strong one. So particularly RNA viruses have to be very cautious how much change they can make it. In this case, even though we have mutation, they are not in the area really so much so on the receptor binding site. Receptor binding sites has only 201 building block, amino acid residue, building block of this protein. And that area is the one responsible for recognizing the receptor of the human cells in the surface. However, within this 201, only 70 residue, 70 building block, you can see brick, are actually have the binding motif, not all of them. They are surrounding the helper one. So even that 70, if they change too much, the virus will not survive. Receptor will not take them, virus will not bind. So they cannot really change too much. There is a constraint there completely. So to my view, virus will not change too. We will, because the vaccine is made targeting that area. So vaccine will be good for this infection. Not be 100, may not be 100% as far as this disease is concerned, but it will still perturb the infection. Definitely, even though it's less amount. For any variant, it's the same thing, because the vaccine was made from original one. They cannot change too far. That virus is no longer can replicate, no longer can enter. So that is my own view, and scientific view that and one more point I want to say: the spike protein itself are very few in the virus surface, the trimer, and most of them are in down. That means they're non-functional. Only up one are the one can touch the receptor. So they're very difficult for virus as well if they change that few spikes, So I think that we are talking about, we are saying something that we're just predicting because the gene sequence only said that much, not everything. Genome sequence is actually is a protein, how much is changed, that's the point. And that we will know, we don't know yet. But I really believe that it's not going to be so much more dangerous than any other circulating right now.
Right. I'm going to come to vaccines in a moment. So can I prod you a little more on that point then? So if, as you say, there is no conceptual difference between, let's say, the previous strain of COVID-19 and the current strain, I mean, but there are differences, but it's not conceptually so different. Purely from a layperson's point of view, then why is the scientific community, public health professionals reacting so with such panic, for lack of any other word?
Because they are looking into just the sequence, which is the nucleic acid in the sequence. And that has to then translate to the protein. And that protein have to be very, very tolerable for the virus as well. And they may not. If they're not so tolerable, they're not going to be functional. That's what I'm trying to say. The virus itself have to survive. And it may be more transmissible. That's this infection doesn't mean that it'll cause more disease. So we have to separate infection versus transmissibility versus the disease. So disease outcome would be very similar. I don't think there will be any difference. Whether it's alpha or delta, it'll be same thing, same sort of disease we are going to see. If we see any severe one.
But that's right, and that's an important point. You're saying that if you look back many strains, including delta and the alpha or the earliest strains, you're saying that the disease impact is still roughly the same?
Yes, absolutely. There's no difference really that way, because the outcome is the respiratory disease is the same. Is that the question of the human being who infected their immune system is the major problem. If they're not vaccinated, and we have a better scenario right now because many of us are vaccinated. So even with the one dose, we're going to be some protection, and 2 doses or 3 doses, even far more. So it is not that easy for virus to just take over. It's just not possible. If that happened really, virus changed tremendously, we would have known before. Virus is already around, this one, even though we did not detect it. It's not that suddenly coming from South Africa. We stop South African to come. That's, I think it's just makes me think, how can they think that way? Because virus is everywhere. It just doesn't, these days, people are traveling everywhere. And then, now today I hear they have, Netherlands have this isolation before this virus is before in Netherlands and then in South Africa. South Africa and Netherlands, they are Dutch country people in South Africa, that continuous movement going on. And something there will become here, something here, they will go there. So I think that is not the reason that we think that South Africa started it first. The same way I thought the Delta come from India. You don't know where it come from actually. We isolated first time, we recognized first time. Doesn't mean that they were really there first. The problem, I think, the place that in South Africa they first seen it, it is most likely that it immunocompromised because the many HIV infected people are there, and they're very immunocompromised, and they are not vaccinated. And if one of them have this virus low level they did not detect, and they're chronically infected, slow growing, and the virus cell to cell spreading, we don't know, and then mutation going on in one body, not because of different people, and then bust out all this virus, and then infected the next one, maybe the most vulnerable one first, like that they spread. So we have to see also virus point of view, how the virus work really, and RNA viruses. And I think that I would not believe it's going to be very different than, is already we see the common changes that we have in Delta and Alpha. And if you look carefully, we'll see same kind of changes the other variant has already probably. So this is a combination of that probably.
Right. And you talked about transmissibility. This is for our readers and viewers as well. So could you explain that a little more, and maybe once again, what does it mean today when we say that a virus is more transmissible? Does it mean that people, earlier if you said maybe a 6 feet distance is ideal, maybe this virus could transmit in 12 feet? Or what does that mean when we say that a virus is more transmissible?
It is something, of course, this is a respiratory virus, so you have to inhale. But main thing is that if you are infected with, say, 10 particle of virus, so you are not going to spread more than 1 or 2, okay? If you are infected with 10, which you are very, very susceptible with the virus, and you make it now 1,000 times more. So virus load become very, very, very huge amount, very intensive amount. When you sneeze, you are excreting a lot of virus. So it will spread to many people, So, and they go easily to the people, because now this virus they're talking about fitness of the virus. The viruses have a better fitness to go into the body, another person's body, and transmit. All variant is the same quality they have about the distance wise. That's no different there. It's the amount of virus, how much virus they can spread. So if a immunocompromised person had a lot of virus already making in his body, and then he's spreading whenever he sneezing, and the distance, I think I mentioned before, that is same like if you can smell somebody smoking somewhere, you smell it, that's the distance we can think about. It's nothing to do with 2 meter, 1 meter, or touching people who are washing their vegetables, I understand. Nothing to do with that. It is inhaling through the nose, it's main thing. It goes in. Not by touching.
No, you've not mentioned this earlier, but the smelling cigarette smoke is an interesting analogy to I guess remember. So let me come to vaccines.
So many people, probably I said to somebody, I can't remember.
Yes. Okay, so let's talk about vaccines then. Since we last spoke, which was several months ago, obviously there has been much progression in actual vaccination across the world.
Yes.
Not so much obviously in Africa, and that's one reason why people are more concerned. But in many other parts, the proportion of vaccinated people is quite high. In India too, it's rising steadily. But obviously there are people who've not taken it or are not able to access it. Again, in many parts of the world, including the Western world. So, two questions. What does that mean? When we've not obviously have full populations fully vaccinated in general, and two, in the context of Omicron and the vaccine's efficacy.
As I said, Omicron, even they have some changing, they are not going to escape all the immune system things. Their epitopes, different. Maybe one change a little bit. So vaccine is going to still be protective. And vaccine is the only way we can really stop the spreading of the virus, definitely. The best way. Of course, you can do these physical isolations and masking and all this stuff. Also, of course, there's help. And I see people have masks, they cover their mouth, not the nose. What the rationale I don't understand is the nose is the most important. They have to understand that. Second point of the vaccine, I think that it is a vaccine hesitancy. There's so many communities in different countries believe vaccine has some kind of spooky thing on it and something contamination, which is completely rubbish, of course. All vaccines that are made so far are good vaccines. Really, all of the vaccines are good. Any of the vaccine available is good for take if it's that available. And I'm keeping on telling everybody, try to make your own vaccine in your country. It's manufacturing part, they have to do. Otherwise, it's not possible to protect everyone. But I understand that even the vaccines are available, people don't want to take, even the young people. It's a misconception they have. And that is also very true in India. And I think that is important in India to talk about it, discuss to the common people, simple way. Because if you are sick with the vaccine, you'll be sicker, much more sicker, if you had the virus. Because vaccine are made very small amount. It's not the old-fashioned vaccine that people used to make before. The small, generally, other than your Covax, which is the inactivated virus, is the whole virus that. But they inactivate the genome completely, and then they're using the protein as a vaccine. So much more carefully done these things, because nothing will be released without careful testing. In any country these days, it's a very strict regulation for those things. So anything in the market available properly, government regulation gone through, they're good vaccine. Best one, in my mind, is messenger RNA vaccine, of course. Messenger RNA vaccines, the one Pfizer and Moderna, they show higher protection rate. That's why they're better vaccine, I think, because they're targeted. And other vaccine, probably, I think the next one, I think the Sputnik vaccine is very good, because the way they designed the vaccination, same adenovirus, but they designed differently, 2 doses, and that gives very good, strong protection.
Right. So 2 questions again. So one is that if you're saying that all the vaccines that that exist today are good enough to protect us against this new variation of Omicron, then do we really need a new type of vaccine to address this variant, as one of the manufacturers was talking about? Or do we need booster shots?
So booster shot is, let's talk the second question. But booster shot for any vaccine means they raise your antibody level by boosting. So more antibody you have better chance to protect yourself from the virus infection. So even something with the change virus, that's Omicron from say Alpha or Delta, still it will change, but protect. But if you think about virus vaccine was made on the Wuhan strain, everything, not Alpha, not Delta, but they protected all of them still, even though the mutation gone. The Delta has a very, very strong mutation, 2 of them. And there are changes. However, still we get protected. We got protection very well, actually. So I believe the Omicron will be, virus will be protected, but we can probably have less protection than the original virus infection. But that doesn't matter. Still, we will not probably get disease, mild disease maybe, and that's what we think that going to happen. New strain vaccine made on the new strain, continuously they have to make it, they do for flu now. It's a good idea. It's not difficult to make, very quick. Few months only takes for this. With the technology is very novel, that for mRNA, particularly very easy to do it. And same about adenovirus-based vaccines, AstraZeneca's or Sputnik or Any of that is Chinese made also. So none of them are difficult to make. They're simple technology for virologists, really. All virologists can make it almost. Genetic engineering, like my lab can make very easily. The point is that we have to, right now, these vaccines are available, so we should take these vaccines while we wait for the others. But another variant will come also. You can't stop that. No way you can stop. And you cannot really always say, we're going to stop this country to come in our country. You stop this country. It's just not feasible. It's not practical. How long you can do that? We are a global community. It's just not possible to do that sort of thing. Precaution you have to take, but you can test them. Anybody coming can test and see what happened, whether they have the virus or not. That's fine, but telling them, punishing like that, South Africa discovered, so they are now banned from any country. It is unfair to them in a way.
Right.
They are the one released the information, They could have just kept it a secret, But they said it, they said openly, and that's what we know that this strain exists. But some other people, some other country might have it, but nobody looked for it. So this is the way I feel.
Yeah, exactly.
I'm not afraid of it.
Right. So the identifying the genome or the sequencing, I guess, is an equally critical component. So as you look ahead now, I mean, one is that the scientific community also is saying that we should wait for more data. What would you be looking out for in terms of the behavior or the characteristics of this particular Omicron virus?
They want to see is this virus can be neutralized by the antibody that raised by the vaccine, That's what it is. Can they neutralize? That's the first thing they're doing, everybody. How much they can neutralize this new virus. If we know that they can neutralize, then it's very good. You're not going to get 100% neutralization, but this is a simple test. So it's not going to take time. They will know that. Second thing, of course, you can look into the protein theoretically, bioinformatically. You can look at the protein changes in that particular area, not the whole spike, particular area that binds with the receptor, and see what changes are still tolerable for the virus, or interaction between virus and receptor interacting site, because they're very small space. It's not that easy. If they too much change, they cannot accommodate. So it's very easy to do that. Every country can do that because they have the bioinformatics system everywhere, even though they don't have the, say, sequencing system so quickly, but bioinformatics, yes, they can test that very easily. So
right, and last, go ahead.
No, that's all right.
Yeah. Last question, Professor Roy. So what are you looking at now, and what is the kind of inputs that you would be seeking, not just from this particular variant, but in general from the developments that we've been seeing in the fight against COVID-19, and how are you looking at the horizon?
Well, one thing that, there are a couple of new, probably you heard, new drugs are coming out, or they already, one is the stopping the polymerase to work. That polymerase to work means it cannot amplify, but it has to be given very early, right in the infection time. And second one is called protease inhibitor, because once they make the protein, they have to modify by cutting them in a right sort of pieces that make the virus component. And that part also they have. There's a Pfizer and Merck, two companies, and that will be very good, both of them. They're targeted drug, really. Not just any drug, they're targeted for this COVID, all the COVID polymerase or COVID protease. Those are common almost. So I think that's very good. And second thing, everyone trying now better vaccine. Better vaccine means more safer and longevity of the antibody that sustain for a long time. And that's what I believe very strongly. The longevity of the sustainability of antibody is very important. You cannot continuously giving injections again and again. One more thing that I want to tell, because this paper came out a few weeks ago from Nobel laureate in California, Berkeley. And what they have done, they made a system that they can screen very quickly which virus is better fitted, higher fitness than the other variant. They test all of them. They made with all the protein, not spike. The spike sits in another protein of this, it's called membrane, and then that sits with another protein called nucleocapsid. And then the one protein called E protein envelope that make the shaping of the scaffold that spike going to sit. Everyone has to be correctly coming together. So they make that, and they're showing that which protein is the driving seat, not the spike, nucleocapsid, because that one take the genome inside the capsid, and also when they go to the next step, they release the gene. So this one decide mutation on that one is going to tell us. So I think, because in Delta they tested, and Gamma they tested, and Alpha they tested, not the spike had not too much effect on the virus spreading, is the nucleocapsid mutation. Same time the mutation going on there, nobody looked, but they have looked on that because they had the system to look. So it's a fantastic paper. And virus-like particle is, is my cup of tea. I have done it first for many viruses. And I just have COVID virus-like particle as well, just sent out for publication. Those are the better quality vaccine will be, because they have all the different component, will give cellular immunity as well as, neutralizing antibody and all this. So that will be the future. Some manufacturer will make it someday. And I think they are trying those sort of things. So this is our future going to be.
Right. And that's an optimistic note indeed to end on. Professor Polly Roy from the London School of Hygiene and Tropical Medicine, thank you so much for joining me.
Thank you for giving me this chance. Thank you very much.
My pleasure. Thank you.